Now all of that has been using the formulas for finding and solving triangles or finding areas. But how do we use it in applications? So here's measuring a baseball diamond. The bases on a baseball diamond are 90 feet apart, and the front edge of the pitcher's rubber is 60.5 feet from the back corner of home plate. Find the distance from the center of the front edge of the pitcher's rubber to the far corner of the base. So let's draw the picture. So I've got a base, this is my home plate, and there is third. So I've got 90 feet from here to here. I've got a pitcher's mound here, and I've got, so this is first, this is second, this is third, and this is home. Now they tell me that I've got from here to here is 60.5 feet. And it's going from the back of the pitcher's mound to the front part. And we want to know what's the distance, how far is the front edge over here to first base. It's C. Now we're not sure it's a right triangle, so we cannot assume that it is. So I have, and they tell you this is a square. Okay, and we dropped, we've got this here is 90 degrees, so this would have to be 45 degrees. So now what am I going to do? I got to find C. I have angle, side angle, so I'm going to use the law of cosines. I need to find C. So let me write that down. C squared is going to be 60.5 squared plus 90 squared minus 2 times 60.5 times 90 times the cosine of 45. 45 is one of those nice triangles, and I'm just going to put the square root of all of this that goes in there and plug it into my calculator, and I get approximately 63.7 feet. Is how far the front edge of the pitcher's mound is to the first base. Now if we're looking at estimating the acreage of a plot of land, this happens to be exploration on page 492. So I'm going to read it to you. Jim and Barbara are house hunting, and they need to estimate the size of a irregular adjacent lot that is described by the owner as a little more than an acre. With Barbara stationed at the corner of the plot, Jim starts at another corner and walks a straight line toward her. And he counts paces. They then shift corners, and Jim paces again until they have recorded the dimensions of the lot in paces. I'm going to draw the picture. They later measure Jim's pace as 2.2 feet, and what's the approximate acreage of the lot. So let me draw the picture. So we're going to try and find the area. These are in paces, so we're going to find the area of each one of these using Heron's formula. So for triangle 1, we're going to find the semi-perimeter, 81 plus 112 plus 115 divided by 2. And then to find the area of the first triangle, we're just going to take whatever that is, and then we're going to take that number minus 81, and we're going to take that number minus 112, and we're going to take that number minus 115. And when we put this in the calculator, we're going to get an area of the one triangle. We're going to do the same thing to the second one. Okay, so I took the area using Heron's formula of each triangle. I actually went through and found the semi-perimeter, and then I plug it into Heron's formula. So this is the area of the second triangle, the area of the first triangle. I added them two together, and that's the total area in square paces. The next thing we need to do is a unit conversion because they want us to put it into square feet. So now what I'm going to do is I'm going to take paces, and in the exploration they told us that one pace is 2.2 feet, and I have to square it. And when I do that, the paces will go away, and I will get the square footage. Okay, the square footage ends up being 41022.6 square feet using the unit conversion. Part 3 tells us to change the square footage to square miles. Don't know why, but that's what they want us to do. So I'm going to take 41022.6 square feet, and I know there's 5,280 feet in 1 mile, but this is squared, so I have to square this. Now let me plug it in my calculator and see what we get. All right, looks like we get a very small number. It happens to be 0.00147 square miles. All right, let's look at the next part. All right, for part 4, what we need to do is they want us to change, in 1 square mile, there are 640. So we're going to change the square miles to acres, to square acres. So I have 0.00147 miles squared, and they tell me there's 600 in 1 square mile, there's 640 square acres. And when I put that into my calculator, I'm going to get 0.9417 acres squared. Let's see what the next part says. Part 5 says, is it reasonable? Remember that the owner who is selling the lot says it's little over an acre, and they're finding it just a little under an acre. And it could be very accurate because they did it by pacing instead of actual measurement. Do they need to doubt his estimate? Probably not, but if they want to know if it's an acre, they probably should get it surveyed. Would they be able to modify the way they measured it if it's an irregular lot with 5 straight sides? So in other words, if I had 1, 2, 3, 4, 5, would they be able to estimate what it is? And the answer, of course, is yes, because we could always get triangles. And if we can make it into triangles, then we can use Heron's formula.